In this lesson, we're going to look at some new ways to find that two triangles are similar. We have one way already, one shortcut that is, and that is angle-angle. So with our angle-angle similarity, we have these warm-up problems that we just did. If not, you can pause the video and do those. Let's take a quick look at them. With these problems here, we're looking for angle-angle similarity, all right? So angle-angle similarity, we can say ABC, which triangle is ABC similar to? Well, ABC, we got some vertical angles here, and a good answer there might be ABC is similar to triangle DEC, okay? DEC, that's a good way to go. So this guy here is similar to this one because it's got two congruent angles, okay? Get that? And then we got this FEG, that's this little guy down here. And, well, let's see. We've got two right angles there. And it also shares this angle E. That angle E in that triangle is the same as angle E in this triangle. All right, so triangle FEG, we can say is similar to triangle, let's see, that'd be CED. All right. And since these are similar here, we could also connect the FEC and ABC, sorry, FEG. So they're all similar there. Let's see, what is ACB congruent to? Well, ACB is equal to what we already said there, angle DCE. Okay, angle FEG is congruent to, we got lots of different options there. You could say this angle A, that's actually angle B, huh? Angle ABE. You could say, well, let's see, is that about it? That's about it, yeah. So that's congruent there. So that's the idea. So we got those alternate interior angles. And then down here we got angle ACE, and that's this outside one right here. And so that one we could probably say is congruent to its vertical angle over there. So measure angle BCD. And angle AD, well, AD is going to be parallel to FG. All right. So that stuff there is using angle-angle similarity. So our angle-angle similarity says if we've got two angles that are congruent, like there's a pair of hundreds, and maybe this is 20 and this is 20, then those triangles would be similar. Well, what if we don't know angles, but we know sides, and all we know is sides? Would that prove, or would that make the triangle similar? Well, let's explore that a little bit there. I'm going to open up this this GeoGebra link that you have in your classroom. If you want to open up, you can as well. So here we have a couple triangles, and we got some sliders. And I want to watch what's happening when we move these sliders. What's changing? You can kind of tell by the colors. The colors correspond to the sides. See that there? Okay. And so we can move the triangles around there. But by moving the sliders up top here, that changes the sides. So if we set the three sides, we get the first triangle. Now, the second triangle is affected by this. What is this number doing? Think about that. As it gets larger, the second triangle gets bigger. As it gets smaller, it shrinks. This is our scale factor, all right? So our scale factor for multiplying all the sides of the first one to get the second one, all right? Now, so we've got two triangles. We've set some sides. We've got a scale factor. The question is, are they similar? So let's see what happens here. As we slide this slider, it's moving these little pie pieces. And what is that showing us about the angles? That angle fits right there, and this angle fits right there. Oh, that's interesting. So those two angles are congruent. Well, if the two angles are congruent, what does that mean about the triangles? That means they're similar. So moral of the story is if we set the angles here so that the angles are proportional, and that's what we get with this right here when we're setting the ratio. If the angles are, or if the sides are proportional, then the angles are congruent, and so the triangles are similar. So, moral of the story is this: we can get two similar triangles if we just know the sides. So if we have 2, 3, and 4, and let's say this is like 6, 9, and 12. Notice they're all 3 times bigger. If they're all the same multiple, they're all proportional, then the triangles are similar. All right, flip the page with me. So down at the bottom, there's that similarity theorem, right? So the question is, or what we see here is we see that if the sides are proportional, then the angles are similar. So here's a question for you. Is DEF or GHJ similar to ABC? So we want to see, are these similar or are these two similar? One of those pairs is similar. And the way we find out is we're going to make some proportions, all right? So we're going to make a proportion. Let's take 8. And what does that correspond with? Well, that corresponds with 6 over here. Let's take the 12. That corresponds with the 9. And 16 here corresponds with this 12 here. Now, the big question is, how do we know which way to match them up? And it's important to realize and to see that we're matching the smallest one in this triangle, 8, with the smallest one in this triangle, 6. 12 corresponds, 12 is the medium one in this triangle. What's the medium one in this triangle? 9. So 12 and 9 get matched up. All right? So real important that those are matched up correctly. All right? And so the question is, are these the same? Look at those ratios. Are they the same? Well, the way to find out is to simplify them. You can either divide them out, go to a calculator and divide 8 divided by 6, or just simplify these. 2 goes into each of those. It's 4/3. Okay? And here, 3 goes into each of those. Divide the top by 3, we get 4. Divide the bottom by 3, we get 3. Here, divide the top by, the 4 goes into both of them, so let's divide by 4. And we get 4/3. Hey, they're all 4/3. So those ratios are all the same. So we can say that ABC is similar to DEF. So triangle ABC is similar to triangle DEF. All right, so there is one solution. Now the question is ABC similar to the far right one? Well, let's check that out. Let's make our proportions. We're going to match the smallest with the smallest. 8 with, well, we got 8 over here. We got the medium one, 12, with the medium one over here, 10. The 16 is the large one over there, and the 16 is the large one over there. Are these the same? Is 8 over 8 the same as 12 over 10? No, it's not, because this guy's 1 right here, and this is not 1. This simplifies to 6 over 5. That is not 1. Or if you divide it out, you're going to get 1.4, okay? And this one over here is 1 also, and obviously 6/5 is not equal to that, okay? So this one's just out of the picture. So if 3 sides are proportional, then the triangles are similar. On the next page, we get a similarity situation where we're going to make a proportion. We want to make these similar, so all the sides will need to be proportional. So if we make some ratios here, we've got like 4:12. And now you pick which one you want. Well, maybe you pick 8. What does 8 correspond with? It's going to correspond to this one. The reason is because BC is the notice BC is the second 2 over here, and EF is the second 2 there. So BC and EF are similar there, okay? Did we mix that up? No, we didn't mix that up. Actually, I just read the wrong ones. AC. We want AC there. So AC matches with DF. Okay, so let's make our proportion. We've got 4 over 12 equals 8 over 3 times x plus 1. Let's cross multiply. It's a proportion. 8 times 12 equals 4 times 3 times x plus 1. Okay, so some quick multiplying here. This is 12 times x plus 1. Distribute that thing out. We got 12x plus 12. And 8 times 12 here is 80 and 16. That's 96. Okay, so all downhill from here. Not too tough, hopefully. Minus 12, minus 12. And we get 84 equals 12x. Let's divide by 12, and we get x is 7. All right, well, that's the picture, all right? So that's the idea. We want all the sides to be proportionate. They make these ratios that are congruent. All right. We're going to skip this one for now, so let's jump to the next page. So the next one and last one we're going to look at is side angle side similarity. We have this with congruence, but here's a little difference. This is with sides, all right? So here we've got a little GeoGebra, and we can move a few things here. Let's see. There we go, okay? So we have an angle. We can set our angle here, okay? And we can set that angle. So right now I got this angle of 44.14. So the angle is set, all right? And I'm going to set my ratio, okay? So my scale factor. So here is my scale factor. Maybe I'll set it at 2 to make things easy, all right? So what's going on here? So we have 3.26 and 6.51. They're doubled. All right, got some rounding going on there. And so I've set the angles to be the same and the sides to be proportionate. All right, so the sides are the same ratio here. Whoops. Okay, so the question is this going to be similar? So I'm going to make a triangle here. The last one already is. And let's see if it comes out to be in the same ratio. See if I can get that to land on that dot. Right about there. Okay. And let me see. Well, pretty close. Okay. So, it's not quite on there, so we're a little bit off. But notice this. Okay. When I close that triangle, I get two sides that are twice as big, all right? So the moral of the story is this. When I set two sides and an angle, the end result is that the triangles have to be similar, all right? So let's go ahead and put that guy away, okay? So this is our side angle side similarity, okay? And what this says is if two angles are proportional, two sides are proportional, and the angles are congruent, then the triangles have to be similar. All right? So notice that the sides that we're talking about are the sides that make up the angle. All right? That's the key. So let's try these ones here real quick. Are these two triangles similar? Well, do we have congruent angles? For sure. Are the sides proportional? Well, we got to check those out. Now, a good way to check this out is we need to make a proportion, all right? So look at these two sides that make this angle. Let's make a ratio out of those, 3 out of 2. Notice big one's over larger. Now let's make a ratio out of this one, a big one over smaller, 4.5 over 3. And are those equal? Well, we can test that out by cross multiplying. 2 times 4.5 is 9. 3 times 3 is 9. So, yep, indeed, they are similar. So these are similar by side angle side similarity. All right? That's the idea. So all we're looking for is two angles that are congruent, like R is congruent to N. And are the sides proportional? Let's check here. Let's make a ratio out of two sides from the same triangle. Probably the easiest way to go is take the two sides from the same triangle. Okay, here let's put 21 over 18. Okay, are they equal? We don't know yet. Let's find out. If you want, you can just simplify the fraction. Let's simplify this. Divide top and bottom by 4. You get 7/6. Divide the top and bottom by 3, you get 7/6, and those are definitely equal. So these are similar by side, angle, side. Similarity. That's our abbreviation for it. Okay? On this one more, we've got some right angles, and then we need to check the ratios. So we're looking at these two little triangles here, this one down here, and this guy over here. So let's see. Let's look at the ratio of two sides, okay? The two sides that make these angles that we know, okay? So talking about these angles, so we're talking this 12 and 16, this 12 and 9. We actually don't care right now about the 20 and the 15 unless we wanted to use side, 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 so which we could. But let's use side, angle, side. So looking at this left-hand triangle, we have a 12 and a 16. Let's make a fraction out of that. And then looking at the right-hand triangle, the two sides that make up that right angle are 12 and 9. And the question is, are those equal? If they are, then we have what we need. And if we cross multiply, that's 144. 9 times 16 is 144. So yes, by side angle side similarity, they are similar. Okay? So, all right, that's the idea of side angle side. So we have two new ways, side angle side, where two sides are proportionally angles congruent, and then side, side, side. Those are new ways to prove that two triangles are similar. So, go give it a try.